Elias can do, yeah, thank you, Bill.
Bill.
Hello, everyone. I'm Kenneth, and I'm joined by my apprentice here.
I am Elias. Oh, hello, I'm Elias.
Yes, he has become far more powerful than you have ever imagined. But yes, today we are talking about APIs. Very cool.
Yay.
This is where we're at. And on Friday, we're going to have a workshop uh, into a little bit about hacking into APIs. So you'll have fun with that. Yeah, we're pretty far into the semester. Seems like we're just starting it, but it's crazy, you know. And here's Bill.
I like this lifesaver. Uh, we had our RVB last week on Saturday. Thank you for everyone who participated. Um, really impressed with some people, and I know some of you were first timers. As you can see, almost half of you guys were half timers. Um, not bad, not bad. And majority, I would say, they felt pretty good about RVB. Definitely, we're gonna review your feedback and take that into account for next year. And we have our CPP winners. First place was What's a Terminal, which is mostly the NCAA team. Second place was Swift in Time. They are, I think, Clemens pals, young right there. And then third place was my pals. Yeah, I think Raymond's here. Yeah. So thank you for everyone participating, and hopefully see you next week. I mean, next year, next week.
Well, wait a minute. Is that Jacob?
Oh, wait. Oh, Jacob, that's you. Look at that. Oh, I grabbed his attention. Look at that. Yeah, I guess RVB was announcements, so yeah, you gotta enjoy a picture of Palmer. So who am I? I'm Kenneth. I'm a third year CIS student. I currently work at LADWP as a cybersecurity intern. And if there's anything you gotta know about me, I like cybersecurity, dinosaurs, and Star Wars, as you can tell.
All right. I am Elias, third year CS student. I am a current Swintern, and I do like cyber, but not dinos or Star Wars at all.
But yeah, I really enjoyed working with Elias, and together we were an absolute unit, you know, just like this DC-17M interchangeable weapon system. So this is our table of contents, what we're going to be going over today. First, we're going to be talking about what APIs are, and a little bit about REST APIs, then some of the vulnerabilities that APIs have, and finally, a little sneak peek on the workshop on Friday.
All right, section 1. Anakin's pretty impressed. I'm gonna be pretty impressed if you guys learn something about APIs. Let's get into it. All right, what are APIs? They are application programming interface. What does that mean? It acts like a bridge between software to exchange information seamlessly. It's used in data manipulation, retrieval, and automation across applications. Applications send requests to the API to act as a proxy between the systems. But why is this important? If you're just retrieving information from a database directly, that could be very insecure, and that's not good. If a lot of people are accessing the database, it can be prone to security failures. It's also helpful for abstraction. The clients don't need to know everything that's going on in between, and they don't really need to know what's in the database or how it works. They can just send a request and they get back what they need. Another reason it's helpful, more on the programming side, it's standardized. If APIs are used, there's common interaction between the database and the APIs, as well as if you're remodeling, say your website, and you don't have to remodel the whole infrastructure to actually access the database. There's a level of decoupling allowed since everything's standardized. All right. Let's see, I have some notes on these. Here, you can hold this. All right, so these are the different API variants. For web service APIs, these allow for software applications to communicate over the internet using standard web protocols. These are just some examples of those. Library-based APIs, they're for programming specific, and they provide a set of functions or methods that can be used to interact with libraries for coding languages. Class-based APIs are similar, just for more object-oriented programming languages for interacting with the classes and objects. The OS functions and routines APIs for operating systems specifically. Yeah, they're used for file operations, process management, memory management, etc. Just other operating system stuff. For object remoting APIs, those are for accessing across machines. If you want to manipulate remotely, that's the main use for these. And then hardware APIs for hardware, if you want to interact with printers, scanners, stuff like that. Just some context for the different kinds out there. All right.
Thank you, Elias. I think that was enough. You guys can like take a nap. I'm sure we're all pretty tired. Dang, okay. But yeah, we're going to be focusing on REST APIs, and now we're going to go into why. So what are REST APIs? REST actually stands for Representational State Transfer. May not seem like much, but it's used in a lot of web and mobile applications because it is interoperable, scalable, and flexible. But really, what does that mean? So essentially, when we say interoperable, it just means that you can use any programming language. You can use Python, Java, C, like anything that your heart desires. And when we say scalable, it means that you can basically put it, because it's stateless, you can kind of just, it's more efficient, and yeah, you can kind of scale it to your needs. So if the database needs more APIs, more traffic, then you can create more and scale it that way. And finally, for flexibility, it means that it's flexible. It can work pretty much in a lot of use cases. And let's say that you change your database, you change something about your database, and another API might need to change the logic within it, but for REST, it should be flexible enough so that you don't have to. It will still keep working. And the main thing that when we see HTTP methods is how it connects. So APIs use HTTP to connect to the web server and the database, and we'll get into that a little bit later. And finally, stateless, meaning that there's no connection made. And when I say this, when an API gets traffic, then it just processes that request. It doesn't remember who it's from, what it needs to do. It doesn't remember any of that. And that takes off a lot of load and memory, which makes it a little more efficient, what I was saying earlier. And if I were to give like an example, let's say I'm putting in an order from McDonald's to Elias. I say, I want a cheeseburger. And then the next day I come back and be like, hey, I want my regular. But Elias will be like, what is that? Yeah, I don't know your regular. He didn't keep the order, and he didn't remember it. So that's what stateless essentially means. So here we have a little bit about the architecture. So here on the left, we have the consumer or the client, and it can be lots of many different things. It can be a web app, your phone, Windows. That's why we use APIs. It doesn't necessarily have to be like a computer. And then essentially what it does is it sends a request through the internet to the API. The API receives this request, and then if everything looks good, then it will send it to the database and fulfill that request and send all the information back. So to get you guys to understand that a little bit more, can I get like 4 volunteers? Okay, Young, my pal, come up here. Thank you. Woo! Elias, you want to call on someone?
Dude, I want Bill really badly.
You want to just ask for them?
Yeah.
Okay. Okay, I just need a minimum of 2. I didn't tell you guys that, but thank you. Young, can you stand here? And Bill, you can be the database. You can stand over here. Yeah. I will leave my lightsaber here. So Elias, does that mean you're the API?
I'll be the API.
Yes, sir. All right, so in my hand here, I have a request. The client wants something. So Young, can you tell us what you want? Open up the paper and tell us what you need.
I need user 1 info.
Yes. Can you show everyone? Okay, so we need user 1 info. And so how is he going to do that? He's going to send an HTTP request, right? And I'll be that. Thank you. Thank you. So then I go to the API and I'd be like, hey, I need user 1's info. Can you do that for me?
Yeah, I might be able to. Let me ask my buddy over here. Hello, Bill. I need user 1 info, please.
Doesn't exist. Yes, what do you need? Everything?
Yes.
Okay, I have his SSN.
Perfect.
All right, go ahead, send the info back.
There you go.
Thank-
I got the info.
Thank you, Elias.
Yeah.
Okay, and then here, client, here's your info. What is the info?
Wow. This is such a weak password. 1, 2, 3, 4, 5, 6, 7, 8, 9.
That's right. We have user 1's social security number. Let's go. And so that's basically how an API works, as you can see. Thank you, volunteers. You may return to your seats.
Awesome.
So for our lab, we're going to actually be using Postman. Postman just makes everything easy and pretty. And so first things, what we're going to do first is we're going to connect to a database. So we have a database already created and everything for you. So we'll walk you through that on Friday. And then you want to set a request type. There's many different types, but we're going to be mainly focusing on GET for this example. And so what GET does is just gets information. Next, we need to set an endpoint, which is right here. And that's just basically where you want to go, what information you want to get from a specific place. And then for parameters, it's optional if you need to. In this example, we don't really need parameters. And then once you hit send, then you should see the results and the output here. So this is breakdown of a GET request. And so in our header, we're going to see the type of request that I've mentioned earlier, GET, then an endpoint. So an endpoint is basically like, I think of it as a synonymous to a Linux absolute path, where you have to specify where in the tree, Linux tree, that you want to go. So on a website like Google, that might just be one endpoint, right? But as you search for anything, let's say dinosaurs, then it's going to lead you to another endpoint. And so that's just basically where you're ending up. And finally here, it's just the connection method in which we're using HTTP and its version 1.1. And for the content type, we have application or JSON. And so this is an example of what a GET request might output, a successful one, I might say, in which it just might be information about user 1. But there are other responses too. So this would be a 200. So I think you guys are all familiar with a 404, right? Not found. So if Elias here gives me a 404 response, then
I don't have anything for you.
yeah, he cannot be found, right? So, right. And another request type that we're going to be dealing with is post. And so post kind of just posts more information. And in this case, we're going to need a login info, and that's where that we would put in parameters for Postman. But same thing, it's pretty similar in how you format it, which is just the request and the endpoint and the connection type. And because it was successful with a successful username and password, we were able to log in.
Perfect. Now I will go over some common API vulnerabilities. This is the fun stuff, what we get into the lab. Let's see. All right, so the first one I want to touch on is SQL injection. Basically, what that means is you're injecting a SQL query into an input from a client to a server. Basically, what you can think of this as, like, in this example, I'm on a login page, right? And usually when you see a login page, you want to input your username and password. But if you're a little mischievous, you can put in an SQL query instead. And that's what I'm going to explain here. So in this example, you got to the login, username and password. Instead of the username and password, you got this little bit of code. And essentially what that does when you plug it in and it's actually processed is you have this quote here. This is just select from users, finding which user you want to get. You close the brackets, so nothing happens. And then you said, or 1 equals 1, which means true. So the statement's always going to be true. And then you comment out the rest of the code. So you don't even need the password. Password doesn't mean anything in this situation. That's why it's gray. It's not processed at all. So since you're selecting from users, and the qualifications is if user equals true, essentially, you're returning all the users because all users are true. So this is one of the vulnerabilities that you can just get a bunch of information super easily if it's unsecured and there's no input cleansing, essentially. All right. So another one we're going to go over in the lab is broken object level authorization. Basically what this is a failure to verify if the user is allowed to access the endpoint. So like Kenneth was saying earlier, the endpoints are a little bit synonymous to the Linux paths. And say one of the endpoints has valuable information. If it's not properly secured, then anyone can access it. The example I put here, service that allows deleting documents. You don't want everyone to be deleting documents. That could get pretty hazardous pretty quickly. So if anyone's allowed to, you wanna make sure you verify their ID first. All right. Oh, next slide. So we're not going to go over all of these in the lab, but these are just some examples of other common vulnerabilities with APIs. The first one, like we were saying before, authentication flaws. Anyone can access anything. That's very hazardous. The next one, unrestricted resource consumption. If there's no cap on the resources you can use, very susceptible to denial of service attack by just sending in a bunch of information back and forth, clogging up the works. Then we have request forgery. If there's no URL sanitization when fetching, basically, if an API is fetching something from a database and someone puts in some malicious code, perhaps, and it fetches the database, it will trust the database. So if you can manage to bait it into taking something like that, you can run something on the other side. So you want to make sure URL sanitized. And then security misconfigurations. There's a lot of settings as APIs get complicated, so you want to make sure they're just up to security standards. Just best practices essentially. And then improper inventory management. This is if APIs are out of date, they can leave endpoints exposed. APIs can have a lot of endpoints, as we've figured out when creating our lab. They can just have a lot of endpoints. And if those are not managed correctly, they can have vulnerabilities popping up left and right. And lastly, unsafe consumption of APIs. This isn't in regards to eating them, but in trusting third-party APIs, some people can just say, oh, the API knows what it's doing, and just let it run wild. You want to make sure that you're still making sure security standards are in place. All right.
Thank you. I know that was a lot of information, so I just wanted to stop for a bit to ask if anyone had any questions. Anybody confused? No, not really. Okay. Well, now this is time for the demo. You know, is anything really like the simulations? Nah. So Elias is pulling up the demo or Postman because that's what we're going to be dealing with. And I will give him a second to do that.
We go.
Oh, that one. Okay, cool. You know this. Thank you. So this is how Postman looks, and like in the previous screenshot, now we can see how it fully looks. So just as a recap a little bit, this is where our database is going to be. In this case, it's DynoBank. And here are some of the requests that you can do within DynoBank. And so here we have our request. And if you do the drop-down arrow, you can see all the different types. I only went over the first two because that's mainly what we're going to be using. And for this demo, I set the endpoint as user/1 because user's going to have a bunch of users, and so I'm just pulling data from one of them. And so, Elias, do you want to explain what this value is?
Oh, yeah. So basically, let's see. In the content type, we have URL encoded. This is basically just for more raw inputs. There's also, what is it? Oh, there's also JSON. Basically, it's just different encoding types for how you're going to input the information into the API. There's just two common types to be aware of, essentially. In some cases, you want to specify one over the other. Just want to play around with that, I suppose.
Yeah, thank you. And so once we hit send, we should be seeing this output. And here, if we do a different user, we can see different things. And yeah, this is pretty format. There's also like raw. You guys can play around with that. And there's also the post request. And so same thing, just different request type and a different endpoint as well. And so within this endpoint, we had specified that we would need some credentials. And so doing this, we get login successful. But if we change a password, then we can see a different response. No. See, now we see that login has failed. So it's a different response because we weren't able to authenticate properly.
All right.
Yeah. We did end a little early, but if you guys have any questions, you guys can ask. Thank you.
What's up?
Oh,
In terms of core values, because they're mostly default size.
Yeah.
So how does that sort of change when you're doing like over the internet or doing
Let me repeat your question.
Okay, in terms of like port values, that was localhost. But how does that change when you are doing it through, let's say, like Wi-Fi, or you're saying you're connecting through like a SSH to something? Like what is there anything that changes in regards to like API? And yeah, that's a good way. Like, does the structure change at all, or is it really just like some slight password protection or some like small security measures?
Like we mentioned earlier there's different types of APIs. So I mean it depends what you're connecting to, because it could be a printer, it could be like a remote machine or something like that. So it just depends on, I guess, the architecture of what you're trying to connect to. Or sometimes it's even like classes in Java. So it just depends a lot. Yeah.
Yeah, so you're just asking about like sorry. You can just go back to the Postman screenshot. Yeah, so you're asking about the endpoint, or? Yeah, so it's just an endpoint. So if we're running it, then we'll give you another like we tested this locally, so it's on localhost, but you're going to be given like a different endpoint, so another IP, and it'll still interact with the same database. Yeah. I think, wait, Jess, did you have a question? Oh, huh? Oh yeah, we're done.
I was just gonna ask, like, are we limited to Postman? Like, do we have to use Postman?
Good question. Postman's what me and Elias mainly worked with, but if you guys are familiar with another tool, you can are obviously feel free to use that.
Absolutely obliterate.
But yeah, Postman to us looks really nice. It seems really intuitive. So yeah, if you guys have other tools that you guys want to use, then you guys can use that too.
Any other questions? Excellent.
Thank you guys again. Oh yeah, and can you go back to the sign in? And make sure to sign in. I forgot. I think we didn't emphasize that, but yeah, please sign the code or scan the code. Sorry. Oh yeah, so RVB stickers are also here if you guys want them. So they look really cool. Yeah, you guys can come pick it up.